So number 14 then for 5 marks. It just says find the general solution to this first order differential equation. Now that's the type where it's not separable. That's the type where you've got to find an integrating factor. That is some expression you can put in here, multiply this by, to generate the pattern for the product rule upon differentiation. And the way you find that integrating factor is you do e to the integral of this part that's multiplying the y, negative 2 upon x dx. I'll just work that out separately. So I'll take out the negative 2, so the integral of 1 over x dx, and you know what that is. That's going to be ln x. Now I'm not going to put plus c because it's a factor. So you can multiply if you like, but they'll all just cancel back out. As soon as you put them in, they'll just disappear. So that's actually ln, take that negative 2 in, makes it 1 over x squared. So that's e to the ln of 1 over x squared. It's important to have the ln on its own exposed so that those inverses can cancel out, which means the integrating factor is going to be 1 over x squared. Now if you apply that to this, multiply them by it, what you'll get is this. The first part will be 1 over x squared dy by dx minus, now multiplying that, it's going to be minus 2 over x cubed y, and that'll just knock out that x squared there, will equal sec squared 3x. So at least that's gone down a bit. See, that's the right pattern now. Then to differentiate one, leave the other alone. Y's been differentiated, so that must have been the original. You differentiate that, you get this, and there's the y alone. So that came from the product of 1 over x squared dy. So if I integrate it back up, I'll get this. I've still got to integrate this side. Sec squared 3x. Well, that goes back to tan. So that goes back to tan 3x, but divided by that 3, but don't forget a plus c. Because that plus c isn't just going to be an innocuous little floating number. Because to get y, I'm going to have to bring this across. So y is finally going to be bringing that across 1/3 of x squared tan 3x plus c lots of x squared. And that's it.